Well, yesterday my VIZ 707 WP707 dual supplyist power supply showed up. I got it at a very special rate, essentially deemed trash, I believe, by the seller. So for a little more than the shipping cost, just a couple of dollars more, picked up this unit. Um, Mostly interested in it because of the transformers and a few other parts that might be of salvage value in it. But we're going to take a look at it. I've got it opened up. Okay, we've opened it up, and I know there was a piece rattling around in here, and here it is right here. Little transformer. Looks like the plastic tie wrap that originally held it in place onto the board. It's quite a bit of weight to be held onto the board like that. That's the only thing they had it onto the board. They didn't even have clips on it. Well, okay. The other part would be the leads themselves. There was they remained soldered to the board. But all the wires to the transformer sheared off, and they sheared off right at the transformer itself. This side I could possibly salvage, but I don't see a single lead on the other side. So that's a goner. However, the nice big whopping transformer here in the middle, which I knew it had. I have one of these and a triple supplyist already on my bench, so I've got some familiarity with it. They provide a dual it's a dual power supply with a voltage and current readout. You select either current or voltage via switch on the front, and you can select the meter to read the power that's coming out of the unit, or you can switch it and you can feed a signal into the unit and use this as a voltmeter. At the time, back in the probably middle 70s, that would have been a fairly powerful unit to have, because people didn't have digital meters like that in at least most of us didn't. Let's put it that way. Okay, well, let's take a look at the information. I can see that transformer probably is the feed, if I remember right. It supplies the voltage feed to the readout board, the two readout channels. Let's take a look at the diagram. Okay, well, we brought the schematic diagram of the WP708, which is virtually identical except for there's a 5-volt power supply, high current power supply on the 708 that isn't on the 707, but other than that, it appears to be identical. And here's the control transformer, and I see that it is feeding power. If you can see feeding power down to this LM309, which is right in this area on this particular channel. And let's see, oh yes, and it also is feeding this channel. So, but they are they're a little bit different in that the one transformer has dual primaries and dual secondaries, so it's essentially two transformers. So they've wanted to keep the voltages isolated from one another. Probably because of all of the extra usefulness of the meters, they couldn't guarantee that you wouldn't short out the inputs somehow. So they're keeping it isolated. So whatever you do with the one meter doesn't affect the other. If you hook them together, they don't wind up shorting out. Anyway, so I'm pretty sure I don't have a transformer like that. I might have some 12-volt transformers. I could probably put two of them in there. But let's see. That's a T301. We'll take a look at the parts list, and we'll rotate this view counterclockwise. Okay. T301. Here we go. T301 display transformer. So yes, it's definitely for the displays. It's a 9605305, which I'm not surprised because it said so right on the transformer. All right, so they went $21.40 plus another $12.95. So that's gonna run me like $34. Yeah, maybe a little more than that even. And that would like double the cost of my unit here. I'm not going to be able to do that. So that's out. Let's think up something else. Let's go to Google. Let's try. We'll look up the LM309. Okay, so we got LM309. We're looking at the information on it. It's a 5-volt regulator. It's meant to work absolute maximum voltage 35 volts. And you've got to leave a couple of volts on the low side, so it puts out 5 volts. So you'd want to put in at least a minimum of probably 7 volts. And you really don't want to have 35 volts. Would be way too much. You'd be wasting a huge amount of, well, 30 volts. You'd be wasting, say, 28 of it anyway, 28 volts. So you want to try and stay within 3 to 5 volts, something like that, of the voltage that you want. So we want to be like 8 to maybe 12 volts, somewhere in there. That'd be a good range. So that's worth knowing. Let's go ahead and think about that. That means if I was to feed a voltage in there of say 8 to 12 volts, we ought to be able to power that board. Let's give that a try. Okay, well, the transformer leads pulled out of the transformer completely and cleanly, and I don't see any wires shorting each other out. So this is the primary side, this is the secondary side. Here's the diodes and the capacitor for each of the boards, and the broken tie strap, which is sort of in the way. Yeah. Okay, so if I get a couple of leads, I'll be right back. Okay, well, I know that I can feed that meter, and I've got the meter on. I'm on volts, I'm on output. What I've done is I've put a couple of test leads going to my voltmeter from the output of this left side of the unit. And I'm going to plug this sucker in and just see if it doesn't blow up on me here. Okay, we plugged it in. And let's power on the unit. Ooh. says 20.0 volts, and so does my meter, 20.0 volts. So I'm getting output from the power supply, and I'm measuring the power supply accurately. That's good. That's good. Let's see what we get out of the other side. Okay. I'm set on 20 here. Obviously I have no readout, but I've got 20 there too. And if I vary the power supply dial, I'm seeing the voltage vary as well. So that's good. So, well, this is very positive. I mean, I've got power coming out of both sides. I can adjust the power, and I've got my meter reading on the left side. Let's see if we can feed the meter to the right side. I'm going to move those clips. All right, I moved the voltage feed to the opposite side of the what would be the transformer, to the other isolated transformer pair, and now my right side meter is working. So both meters, let's see, make sure we get, so that says 20 volts, and I'm reading 20 on my HP, so it's reading accurately too. I can vary this sucker. Let's take her down to 10 if we can. Okay, so this is 15 to 20. My low end right now is limited to 15. Let's make it 15. Alright, that reads 15, and we are reading 15.0. So, yeah, I can adjust it. Everything's good on this. So really, what apparently happened is somebody probably dropped or slammed the power supply down too hard on a bench when they went to use it, and the inertia ripped that transformer right off of that board, and it had to have been a heck of a drop. I'd say they dropped this whole sucker on the floor. I don't see any damage to the case, but yeah, it had to be something pretty major. But that's it. So I've got a working supply. I've got a heck of a transformer in there too. They don't give you a whole lot of information on the transformers. They don't tell you the voltage out or anything like that, so you got to kind of deduce it yourself. But I'm deducing 12 volts looks like it would work just fine. So if I put two 12-volt transformers in here, one feeding each side of the board independently, I think I could make this work just fine. Or two independent 12-volt DC sources, like from a wall wart or something, that would work as well. So we're gonna think about that. But in the meantime, probably the worst thing about this is this absolutely hideous case. Somebody spray painted on it, did everything else, plus it's years of filth. So we're going to see if we can clean that up, probably spray paint it, make it look a little better, clean up the front meter here. And I notice a plate here that's almost legible. Looks like MILW period area tech college. My guess would be Milwaukee area, Milwaukee, Wisconsin area tech college. And it gives a property tag number. And then they went to some trouble to try and spray out or paint over, scrape off property of something SC. I don't know. SC to me would be South Carolina, but maybe it means South Campus. I don't know. But that gives me just an idea of where it came from, maybe. Milwaukee, Wisconsin Technical School. All right. We're going to see what we can do. We'll get back. Okay, well, not having the dual primary, dual secondary special transformer that would mount on this board didn't have one of those. And but I do have a large amount of wall warts, and a good voltage for this would be about 9 volts DC, and I had a couple of 9-volt wall warts, which are right here. And I've strapped them down. I've insulated the leads. I've got the power leads brought over to the point where the power would come onto the transformer. Normally, when you flip the switch on and off, it goes on and off. And then I fed the individual voltages, the 9 volts, to each side of the output that goes to the display boards. And once I got that done, then I gave the display boards a quick calibration, and the calibration is confirmed that my reading is dead on right now on the right channel. And if I look at the left channel, I have confirmation of it as well. So we're looking good. It's working good. The display is nice and bright. We're in here solid. It's not going to move around. And so it does the job. And on top of that, I went ahead and spray painted the rather hideous looking cabinet. Took it outside, gave it a shot of primer, and then sprayed it. It's not perfect, mind you, because they used a grinder and they ground off some of the paint that was on it originally and left some, like you can see here, the indentations, the marks, but at least in color, it's a nice rich color, and unless you catch the light just right, you're not going to notice that the finish is not perfect, but it's going to look really good when I mount this thing back on the unit. So it's totally working. And I'm going to go ahead and clean up the faceplate a little bit, and we're done. All right, thanks for watching.